We're looking at ladder diagrams, and ladder diagrams in exam is around 10 marks approximately. We're looking at ladder diagrams today, and ladder diagrams are approximately 10 marks in the exam. The ladder diagrams, we have the live and the neutral. Alright, so this live and neutral is normally referred to as the rails. Then the horizontal lines will be called the rungs. Now on the rungs, on the left hand side we'll have an input, and on the right hand side we'll have an output. Inputs are normally switches and outputs are normally contacts. So on the left this will be an input switch in green, and on the right this will be an output. Okay, what type of input switch is that? That will be a push to make switch, also called a normally open. So it's normally open. When I press it, it now becomes closed, also known as a push to make switch. Now we're going to change those symbols to the ladder logic symbols. So if I press my push to make switch or normally open switch, I will get an output. So if that was a light, the output, then the light would be lit if I pressed the normally open switch to a closed position. The switch that's now here will be called a push to break switch. This means that when I push it, it will open the circuit. And now the pins A and B will be disconnected, because as I push it, it will break contact between position A and B. The circuit would then be open, and if that output was a light, that light would go out. And that's the switch, what we call a push to break switch, normally closed contact. Now we're going to change to the ladder logic or the ladder logic symbol. And this is then called normally closed. So as soon as power is given here, this means this light will be on. So this means when we take action, we will be making the switch open to switch the light off. So normally this light will remain on, this output will remain active until human intervention is added to the normally closed switch, then the light will go off. So under normal operating condition, this will be an on circuit. Only until it's actuated, it will now be off if we interfere with the normally closed switch. This switch will be in a one state, but when we interact with the switch, when we actuate the switch, it will then go to a zero state, meaning it will be off. So now it will be in an off position. Other ladder logic symbols will be M for motor. As you see, this one will be a heater element, and then we also get what we call an indicator lamp. This one will be an indicator lamp, and the next one we're going to look at a siren. A siren can also be called a solenoid. And the next one we're going to look at is a pilot light. This one will be a pilot light. Then we get this one called CR, which is normally a contact relay, but they also refer to it as a relay coil. Now then we're going to look at some other weird symbols, which are for pressure control and float control. This is like where there'll be a dam or something where there's a pressure switch. Right, so if you look at this one, it looks like a toilet system where there's that round ball in the system on top of the toilet. So we call this one float control. Okay, the next one is pressure control. Both these switches are normally open. And then you get temperature control. And that's how it would look in a ladder logic. That will also be normally open. Okay, here we're looking at a basic latching circuit. But before we go to the latching circuit, let us look at a simple explanation. If that switch S1, which is a push to make switch, PTM, push to make, if S1 is pressed, it will close the circuit, the motor will run. So now the motor is running, I'm pressing the switch. I'm going to have to stand there and press the switch forever for that motor to continue running. This means we'll have to add in a latch via the contactor. So when the contactor closes, the auxiliary contacts will stay closed down. Thereby, I can now release the switch and the motor would continue to run. Let's say, for example, this is my contactor. So when the armature is energized by the electromagnet, the armature would pull to the left, for example, connecting all three circuits. Now L1, L2, L3 will all be connected, but don't forget there's another contact inside here that's also going to lock down the next one. So the auxiliary contact within the contactor will also be energized, and then once that one connects, it'll keep the contactor in a closed state. So adding in the latch, so I can now let go S1 and the latching switch will remain in contact. Switch 1 will be open, but the current will now be flowing through the motor via the latch switch. So in the PLC ladder logic programming, the latch switch name will always be the same name as the motor name. So once the contactor is closed, the motor continues to run. So this symbol where the motor is showing over here will normally be the contactor itself or the output itself. So when that motor is continually running, that S2 will remain closed. Now once this thing latches, we have a problem because we cannot switch it off, which means we'll have to add in a switch to break it. So the only way we can stop the circuits is by adding in switch S3, and S3 is called the push to break switch. So once S3 is pressed, this will open the circuit and the motor will stop, and when the contactor stops, that means the switch S2 will then open and everything will cease to exist. So once the push to break is pressed, the contactor then is no longer energized. That means the contactor switch S2 will open and the motor will not continue to run. We're now going to draw a ladder logic program of the same circuit. So keep this one in your head. Or what I'll do, I'll draw underneath. Okay, so now we're looking at converting diagrams to ladder logic. And this is what we really need to know, how to convert from a normal diagram to ladder logic. Quite easy. So we start out first with our live and our neutral. So we'll need our motor, and in our motor there's a contact relay in it. We'll need a switch to activate the contact relay, switch 1. But once the circuit latches, this means this motor will continue to run, which means we're going to have to add in a normally closed switch that will push to break, in other words. When push button S1 is actuated, the motor M1 will energize, closing the normally open auxiliary contact CR1. CR1 has to be in parallel with that switch. When the push button is released, the closed CR1 auxiliary contact will maintain current to the coil of M1. This will latch the circuit on and keeping it on until S2 is pressed. S2 is also called a stop switch. This circuit is called a basic latch concept. We're looking at delay symbols and we're going to look at on delay. These are timed delays. We get a normally opened, timed closed, and a normally closed, timed open. Next we're going to look at off delays. So we're looking at a normally open, timed open. With normally opened timed open, when the relay coil is energized, contact closes instantly. When the coil is de-energized, there is a time delay before the contact opens. Now we're looking at normally closed, timed closed. As an arrow, when the relay coil is energized, contact opens instantly. When the relay coil is de-energized, there is a time delay before the contact closes. Okay, do some more read up on time circuits just to get an idea. And let's look at how to hardwire the PLC. This is the PLC training module. It's called an EMC 512, but this model is 512 ACR, which is written here. So this actual thing is the PLC, this little box. It's practically like a relay, right? But the model of this thing is written here, and it's also written there, right? Sometimes it says RC, ACRC, so the C is missing. So practically on top of this PLC, there's 8 of these inputs, which is written inputs, but it's on the block itself. These blocks are wired to these holes just so that we can easily connect instead of screwing onto those screws. And here at the bottom you have the outputs. So those outputs, there's 4 of them, are connected to these positions. So this is where your switches will connect to, and the top row and the bottom row is where your output devices will be connected to. So practically your L, right? So on your ladder diagram, your L, and these most likely will be your N's because there's N over there, right? So there's N. So let's see how we can wire this up. Okay, so don't forget, in order for us to run a motor, we need both a start and a stop switch. Right, so into this position we'll connect neutral, and this will be our power source coming in. So this one that I've just inserted here, this will be our power source coming in. Our live will go from here via a switch to these input positions. So let's look at it. Okay, so this red wire that I've just added will connect to an input. We're going to connect it into there, but via a switch. And that will be a normally open switch. Okay, so predict that there's a switch between these two, okay, which you cannot see in the screen, but there's a switch between those two. And then we're going to have a normally closed switch. Okay, I just added in this one, and now this will be my normally closed switch, will go to position 2. Okay, so between here and here is a normally closed switch. Okay, sorry, my mistake. Between here and here is a normally open switch, between there and there. And between here and here is a normally closed switch. Now we're going to start connecting our outputs. Right, we've got our output coming here. This is our out common, so this is on our outgoing side to the contactor. And right, so this is opposite sides of the lead. So from this lead it goes all the way to this lead. This side of the lead is going to go to my contactor, and so this will give me my negative. I'll be getting my negative to my contactor on this lead here. Okay, I switched it to black just to avoid confusion. So my out common, notice this is my neutral or negative, and there's it coming out here. Okay, so this other side is going to go to my contactor on my panel, and obviously for the contactor to work, it needs both a neutral and a live. So I need to get live. Where will the live be coming out? Notice that the PLC has an input, and it has an output. So that means I'm going to get it out of port 1. So out of out 1, this is where my live will be coming out. Out over here is my neutral. My neutral is also, this is the same wire. From here to here is the same wire. And this is my positive. My positive will be going through the PLC. Once the PLC is activated, and the two ends, this will both connect to my contactor. So when the push button is pressed on number 1, when the push button is pressed on number 1, power will go through the PLC and it will come through here, right? And this will trigger the motor or the contactor. And that's how we practically wire up the PLC. So now we're going to draw this into a ladder diagram. Alright, so we have the live. The live must be connected to a start button. Alright, so we have live from this one. From this one, we have live, this position. It's marked L over here, right? It's marked L. Okay, it's marked L. So we have live from that position connected all the way to number 1 via an input switch. Right, there's our live, there's our input switch. Next we're going to need a stop button so that it can stop the motor, a stop button. Right, so now we've got our stop button and our motor, and here's our neutral. So let's look, where's our stop button? Our stop button is number 2, right? Number 2 is our stop button. So when our motor closes and it runs, the CR1 or the contact relay will be engaged, and that means we'll have a latching switch. So our ladder logic looks something like that. Our contact gets both a live and a neutral wire. So our contact gets both a live and a neutral wire. Okay, looking at our PLC, we can see we get our neutral and we get our live. And so here's our neutral and our live that goes to our contactor. Alright, so this circuit is an AC controller via a relay by start and stop push button switches via a PLC. The stop contact in the ladder logic is normally open. That is because the input push button has normally closed contacts. Now, in this ladder logic, you'll notice that sometimes they use the stop button, they'll show a normally open contact. And they say sometimes that this is because that the input push button has a normally closed contact. So with some of these diagrams, you'll find that when it's actuated, then this becomes the opposite. So all you have to do is practically learn these circuits according to the diagrams that are drawn from your textbook or from past papers. So when you see like a forward reverse starter, learn it exactly how it's written there and replicate it in the exam. And that's the best way to learn this topic. Is to study this diagram by heart and learn the explanation by heart. To the circuit, you can also add in a lamp. And what will happen is that this button will be the opposite of that button. So when the motor is running and this is closed, this one will be the opposite, so that that light won't be lit. So when the motor is running, this will be closed, this will be open, that light will not be on. But you can have a second light. Right, so if you have a second light, that would mean that maybe this one and this one will be the same. So that when the motor is running, this lamp is on. So this switch and this switch have to be opposite. Okay, so that's why that switch will be like that. So in other words, when this one is actuated, this switch is in the opposite state, meaning that when this is on and the motor runs, This means this will now be in an off state and this light will be off. This light will be on. So now when this switch is open, this switch will be open and this light will be off. This light will be on. Okay, so that's how that works. Right, next we're looking at a latch circuit where only one motor is on at a time. And so see if you can just draw a normal latching circuit first. Just try it quickly, pause the video. Okay, so first step, live and neutral. Don't forget you need to have a switch that will activate CR1. When I press that switch, CR1 will come on, but however I'm going to need a stop switch so that I can stop it after it latches on. Then once it latches on, that means the control relay is going to, or the contact relay is going to close its switch. That means there will need to be a switch here in parallel. Right, and that's practically our latching circuit. Right, now when the latching circuit comes on, this contactor will be on. So this contactor will have to trigger a switch in order to switch on a motor. So don't forget it's input, output. That output results in an input, which results in an output. So once the motor is running and CR1 remains closed, that means this switch will also be closed. So when this circuit, when this contact is closed, it closes CR1. CR1 being closed will then turn motor 1. But when motor 1 is on, motor 2 has to be off, meaning that the other switch will have to be the opposite of CR1. So if both switches are the same, what would this mean? This would mean that once control or contact relay 1 is closed, that means this switch is going to close, this motor M1 is going to run, CR1 will also close and motor 2 will also run. So we are trying to say that once you press the start button, the contact will close. Once the contact closes, the switch will remain latched on, causing CR1 both to remain latched on, causing both motors to run at the same time. But we want one motor to run at a time, meaning one must be on, one must be off. So with one on and the other off, that means one switch has to be the opposite. Right, and that one will be the opposite. So when this one is on and this motor is running, this switch will then be in the opposite state, causing this motor to be off. When this one is in the opposite state, then this motor is in the opposite state, causing this one now to be on. Okay, so this is how this ladder logic works. It can be somewhat confusing. Alright, as I said guys, that this ladder logic stuff, you have to reread it and reread it to understand it. I read it and I forget. It's a hard thing to understand because it's not like your normal thing that you're busy with every day. Right, so let's draw a normal timed circuit and see if we can draw a ladder logic from there. Right, this next one we're going to look at a start delta where it'll have a timer. So with start delta starters, don't forget it starts first in star to limit the currents, and after a predetermined amount of time it then switches to a delta connection using a timer. So let's try and draw this circuit, a normal circuit, not a ladder diagram. Alright, so we're looking at a star delta starter. So normally we're going to start with live coming into an overload coil. Alright, so this will be our live coming into our normally closed switch. Our coil always has a normally closed because once the overload coil experiences overload, it'll then open. Alright, then we'll need a stop button so that the circuit can be stopped. Okay, so this is your stop button, and at this moment we're still working with the live. Alright, so we're going to have to connect up a contactor that when the button is pushed now, the start button, it must switch on the contactor and that contactor will latch on. That contactor will need a neutral for it to work. Okay, and now we have our contactor connected to both the live and the neutral, and this contactor will work. But once this contactor is activated by that start button, it will latch on, and that switch will be called exactly the same as that contactor. Right, and so it has the same name, and this is our latching switch. So when this contactor is activated, this latching switch will close, this button can now be released. But this will have to go via another switch in the timer that will activate the timer when this button is pressed. Okay, so when this contactor closes, the MC1 normally open will close. Also MC1 normally open 2 will close, and this will activate the timer. The timer normally has a cross and a contactor symbol in it together. And that's our timer. And now when we're going to connect our timer in the circuit, remember, for all things to work, they need both a live and a neutral. Our switches are connected in series. This is the reason why we don't need a live and a neutral for a switch. Okay, and so all what's in red is live and what's in green is the neutrals, just to easily understand the diagram. Now remember, when you with your star delta motor starter, when the timer is activated, this switch must immediately start the timer, must immediately start the star contactor. So this will be a normally closed switch, so that this contactor that controls the star connection will keep the motor running in star immediately. And this is our contactor that will be automatically switched on, already switched on. As soon as this closes, that will close and this will come on, and this contactor will automatically be switched on. This is the contactor that's connected to the star connection, and don't forget that that contactor needs neutral to work. Now the next part, we'll need a switch that will control when the delta must start. And don't forget that contactor that controls the delta will also need a neutral. Okay, what's going to happen here? After this switch is on, so this closes, this timer is going to start ticking. This is already in a closed position. This switch works with the timer. After a predetermined amount of time, this switch called T is going to open. So when the timer kicks in, after that time, this switch is going to open, resulting in this contactor being de-energized. But this one must now be energized. So let's look at those switches. Right, so here we got this one, this switch here, this normally closed switch. What's going to happen? So this switch is closed, right? But this switch is working with the timer. So when this motor contact runs for a predetermined amount of time, this switch will open, switching off this motor contactor. When this main contactor here that controls the motor now switches off, it'll trigger a switch. So when this motor, right, so when this contactor controls the motor, when it is running, this switch will be open. When it's not running, the switch will be closed. And also with these two. So when this one's running, the switch will be opened. When this one's running, the switch will be opened. And they work the opposite way. So that this way we don't have the star and delta being connected at the same time. Alright, so as we say, learn these diagrams off by heart. Learn them off. Right, at this point make sure you have the diagram drawn, because I'm going to now draw the same diagram in a ladder diagram. I don't have enough space to write both and show this one at the same time, so please, if you can just draw this one quickly, and then you can follow as we go and convert this diagram to a ladder diagram. The best thing to do is to flip this sideways. Right, and now you have your live and your neutral. So all you have to do is draw these same things going across between the live and the neutral, and that will be your ladder diagram. So see if you can do it by flipping it this way and following what is happening between the live and the neutral, between the live and the neutral, and draw them between the live and the neutral, following what you already have here. See if you can do it. Right, so first step, we have live and neutral. We need a overload, a stop, a start, and motor contactor 1. Right, there we have it. That was our first line. Don't forget, we need to add in the latch. And in the top run, as soon as the start button is pressed, this will latch on. MC1 normally open at a latch on. At the same time, the star will also run MC2. After a predetermined amount of time, when the timer is kicked in, the star contactor will switch off, and this will result in the delta contactor being actuated. When the delta is actuated, the star will be off. That is, MC3 will be the delta. So remember that the switches work in the opposite order. So when MC3 is running, that means it closes. When MC3 is running, it opens the MC3 normally closed contact in the third run from the top. And so this way the star will not run at the same time with the delta. So the star circuit has 4 states. The off state, all contactors are open. Then the star state, the main and the star contactors are running and are closed. Then we have the open state. The main contactor is closed, but the delta contactor is still open. No current can flow. Then the fourth state, we have the delta state. The main and the delta connectors are closed and the star is open. Right, I hope all this makes sense to you. All the best.